Hello everybody, welcome back to my Flash channel. So we are today going to be going through all the formulae that you need to learn for A-level mathematics, including AS. Okay, so we're going to start off with coordinate geometry. So, coordinate geometry, there are two things that I suggest that you must learn. Now, the first thing is the equation of a straight line. So the equation of a straight line, you might just think, oh yeah, that's y equals mx plus c. Well, the more useful version of that is using y minus y1 is equal to mx minus x1. Let's get that written down. So that's that formula we'll use. Now the other one is when two lines are perpendicular, so they meet at 90 degrees. Okay, so two lines are perpendicular when their gradients multiply to make minus 1. Really useful to know that. So I often look at sequences and series. Now for sequences and series, you are given the sum to end term for arithmetic and geometric, and those are in the formula booklet, which you have for all examples, we think. Okay. Now you're not given their nth terms, so for arithmetic, the UN is a plus n minus 1b. Hopefully I've got that right. You'll tell me if I'm wrong in the comments. But that's what I believe it to be. Now with geometric, the nth term for that, well, the nth term is AR to the n minus 1. Okay? AR, the n minus 1. Like that. Okay? So it seems obvious that you should know the laws of logarithms, but here we go. The laws of logs. Bog standard logarithm law is we've got log base A of x plus log base B of y is equal to log, well, that should be base A, sorry. Base A of xy. So adding logs, multiply together. Okay? Now if we've got same again, and I'm taking one away from the other, that's different because we now have log base A of x over y. So we're taking away, we're using division. Like so. Okay? Now if I've got log base A of x to the power of y, using the power law, quite useful actually, and I have y log base A of x. So I can bring the power up and down depending how I use that. Okay? Now, I've got log base A of A is 1. And we also have log base A of 1 is 0. And also we need to convert between logarithmic and exponential form, of course. We've got bx equals y implies log, okay, so log base B of y equals to x, okay, or x equals log base B of y, whatever you might choose there. So variable acceleration, so we're into the mechanics part now. So for variable acceleration, we need to work out where we're integrating and where we're differentiating. So if I write down suvat down the side of my page here, now suvat doesn't include the initial velocity or the time, so I can get rid of those, but it is a nice starting point. So I've got SVA. Way to remember it is you differentiate your way down and you integrate your way up. That's the rule for using variable acceleration. Now with vectors, it seems like there's so much to learn, and to be quite honest, there is a lot to learn. So if we have the vector AB, you can narrow it down to quite a couple of basic things here. The vector AB is OB minus OA. That's your basic. And then if you want to find maybe the unit vector, so of length 1, so we've got a unit length of 1, you do 1 divided by its magnitude of the vector. Okay? Now to find the magnitude of a vector, you need to be using a squared plus b squared plus c squared. Okay, square roots it. Now, this is using 3D Pythagoras, which you have covered Pythagoras at GCSE, but again, using the A-level way just to find the modulus, essentially finding the length of the hypotenuse, aren't you, of your specific vector. Now, I want to move on to trig. Now, with trig, you've got the bog standard trig identities. So you've got tan theta is sine theta over cos theta, that's your bog standard. Then you've got your Pythagorean one, so you've got sine squared theta plus cos squared theta is 1. Remember, these are identities, so you should have 3 lines and not 2. Okay, so dividing this one through by sine squared, I get 1 plus cos squared theta is equal to sec, not sec, cosec squared theta, like so. Then I've got, dividing this one by cosine theta this time now, I get sine squared over cos squared, so leaving the first one, that is tan squared. So tan squared theta plus 1 is sec squared. Okay, so we're getting there now. So there's also the double angle formula, you're not given those in an exam. So sine 2 theta is 2 sine theta cos theta, yeah? So 2 sine theta cos theta, we'll swap each other. Then you got cosine 2 theta, which comes in 3 variations. Okay, so you should know the 3 variations. So you got the variation of cos squared minus sine squared, and then using that initial one, so the one we started with, we can find the other 2. So we've got 2 cos squared minus 1. Okay, then you've got 1 minus 2 sine squared. So you've got those. Now to find tan, so tan of 2 theta. Tan of 2 theta is 2 tan theta over 1 minus tan squared theta, like so. Also, we need to convert between degrees and radians, of course. So I've got 180 degrees is pi. Okay. And if 180 degrees is pi, then we also want to know those 2 triangles, so we can find out our exact values. So both of these are 45 degrees, got 1 root 2. And the other one, where you've got your 2 angles like so. You've got 60 here, you've got 30 here, so 60 and 30. Okay, and you've got 2 here. Okay, and then you've got 1 and root 3. Okay, write those up. Okay, so with indices, I want to look at indices now. It seems like even into the 2nd year, people struggle with indices, and I don't get why. But it needs rigorous practice in order to do well with your indices. Now, there's the basic ones, which I probably shouldn't have to write down, but I'm going to anyway, for the basic of making this video complete. We've got a to the m times a to the n is a to the m plus n. I'm sure you should know that you know that one. And I'm sure you know that a to the m divided by a to the n is a to the m minus n. I'm sure you know that one. Now, this is where people get a bit struggle with now. You've got a to the m to the power of n is a to the mn, so I'm multiplying the powers there. Now, the next one is using your negative and your fractionals. So you've got a to the power of 1 over m is the mth root of a. Then you've got a to the negative m. A to the negative m, well, that's just 1 over the positive a to the m. Okay? Now, with sectors, there's 2 formulae that I suggest everyone learns, and you need to learn because they don't give them you. So you've got the formula for arc length, which is theta times the radius. Angles, these are in radians, don't forget. And the area is 1/2 theta in radians r squared, the radius squared. Okay, so a nice basic thing there. Now we're going to move on to the calculus section of the course, so that's looking at things like differentiation. You are given the differentiation from first principles formulae, okay, the f of x, okay, so f of x plus h minus f of x all over h, you're given that, to find the derivative using first principles, usually at AS that comes up. Now, we want to look at the key differentials, so I'm going to start with e to the kx, we'll start with. E to the kx will differentiate to k e to the kx. So basically using the chain rule here. Chain rule we'll cover in a minute. Sine of kx. Well, sine will differentiate to cosine, so I've got k cosine of kx. Now on to cosine. So cosine of kx. Well, cosine of differentiates to minus k sine of kx. Again, using the chain rule here. Okay. So what's the next one we can have here? I'm going to put tan on this list. So tan of kx. You've got k sec squared of kx. Okay, again I'm using the chain rule here with all of these. Speaking of the chain rule, I'll do the chain rule in a second. We've got log of kx as well. I don't forget that one. Log of kx will differentiate to 1 over x. Okay, we've got a to the kx. Now a to the kx will differentiate to k natural log of a. Now I like to put that in modulus brackets, but I'll leave them off and just put normal brackets around for now. And you've got a to the kx as well. That doesn't change. So, but we're still using the chain rule here to do this. Okay. Speaking of chain rule, we'll look at chain rule now. The chain rule shouldn't have an e on the end, should it? Chain rule. Well, what is the chain rule? The chain rule is y is equal to f of g of x. Okay, so that means dy by dx. So dy by dx. Differentiate that. I get g prime, or the g of x. Okay. And f prime as well, don't forget your f prime, of g of x. Okay, so we've got that. Make sure I close the bracket. Alright, also the chain rule, we've got the product rule. The product rule, if I've got y is equal to f of x times g of x, so the dy by dx, I'll differentiate that. I've got f of x times g prime of x plus f prime of g of x. That's a basic one, we should know how to do that by now. So I also want to look at integration as part of this. So integration. So with integration, you've got these in reverse. So you can start off with e to the kx. E to the kx, if you integrate that, I get 1 over k, e to the kx. I'm going to put in the plus c's so nobody shouts at me. I'm going to put sine of kx. Now sine of kx is pretty much the same thing, but I get minus 1 over k when you integrate it. You get the reverse of when you differentiate. You get minus 1 over k cosine of kx. Plus constant. Don't want to forget that constant. And you've got cosine of kx. And these should have brackets around it. Make sure you put your brackets around, just to make sure. So I get minus 1 over k. Actually no, I shouldn't get minus 1 over k, I should just get a positive. Excuse me. I get sine of kx. Plus constant. And the brackets around the kx. Because it's k of x, so it's a multiple of that. Then I've got sec squared of kx. Now sec is 1 over cosine, using the third letter rule there. And sec will integrate to 1 over k. Yeah, tan of kx plus constant. So there's no limits here, so I have to put constant into integration here. So I've done sec, then I got 1 over k, of course. 1 over k or 1 over x, whatever you want to call it. I'll put 1 over x just to make everyone happy. Now 1 over x will integrate to log of mod of x plus constant. You must put your modular signs when you integrate. It is vital, especially where we are now. And I've got a to the kx. Did it up the top. I'll do it down here as well. A to the kx, a little bit harder. It's 1 over k natural log of a. Okay, you don't need your modulus for that one. A to the kx. Okay. Now you should put a constant on the end here. I'm iffy with it, but we'll see. So we've got by substitution as well. First thing when you do by substitution, everybody should find u equals and du by dx. Okay, that's that one. Then if you see something like the integral of 1 over x plus 1, x plus 2, that is partial fractions. Final thing I want to include about integration is if you see integrals like the integral of sine squared x dx, then you need your double angle formula knowledge, which is here. Okay, so you've got that as well. Speaking of partial fractions, I want to look at partial fractions now. So partial fractions, you've got your bog standard, 1 over x plus 1, x minus 1, is equivalent to a over x plus 1 plus b over x minus 1. You've got that one. Then you've also got 1 over x plus 1, x minus 1, then, x minus 2. You've got that one. So you've got a over x plus 1 plus b over x minus 1 plus c over x minus 2. You get the point now, yeah? And the final one is when you've got something like 1 over x plus 1, where everyone gets a bit worked up with. It's 1 over x plus 1 times x minus 1 to the power of 2, so squaring that. Now that is an a over x plus 1 plus b over x minus 1, so the same as the first one. However, you also need a c over x minus 1 squared for it to work. Otherwise you will see it doesn't work. I also want to look at parametric equations. Now parametric equations can seem pretty tough, but it depends the level that we're looking at. So things like ellipses, only thing to be aware of, if I've got x is equal to, 2 cosine theta, we'll have that, and y is equal to 3 sine theta. Your cosines and sines can be either way around, it doesn't really matter as long as you know what to do with those. You also need to find what parametric differentiation is. So dy by dx is dy by dt, where t is your parameter, multiplied by dt by dx, because dt's will cancel to leave you with dy by dx. Okay, so you've got that. And the integral, so parametric integration of y dx. Okay, and that will be the integral of y dx by dt, td. Of y dx by dt, dt. Alright, get in there. Now, if you see something like, this dotted line and an angle theta, the gradient is the opposite over the adjacent. Well, the opposite over adjacent is tan. The gradient of this line is the same as tan of the angle. Really useful to know that. So, forces. With forces, we need to know Newton's second law. We need to know that Newton's second law tells us that the net force is the mass times the acceleration. We also need to know that weight is mass times gravity, and we also need to know that friction, so Fr, is less than or equal to mu times the normal reaction force. Okay? So statistics, or stats as I used to call it, and I still do. So I've got the mean, but I want to use it in sigma notation. So using sigma notation, I get x bar, the mean, is the sum. So the sum of x divided by n. Then you got the variance. Variance is the standard deviation all square. Okay? And you find the standard deviation by square rooting the variance. So the last thing I want to include in this video is about the normal distribution. And if you can't remember this, then you can't access any of the questions that might ask you for a missing mean or anything like that. So I've got Z is equal to x minus mu, okay, over sigma, like so. Okay, so you can't access any of the questions for a missing mean or anything like that when you are solving with the normal distribution. So that is everything. I hope I haven't missed anything else. But if you've got any questions whatsoever, then get me on Twitter. Okay? That's it.